So let's move ahead. Now here we will deal with the JVM and DVM differences. So this is the process what happens at JVM. So initially you have Java source code, then Java compiler converts it to the Java bytecode, and further the Java bytecode runs on the JVM. On the other hand, what happens at the Android is we have a Java source code, then the Java compiler converts it to the Java bytecode, then we have a DX compiler which converts it to the Dalvik bytecode, and further the Dalvik bytecode runs on the DVM, that's a Dalvik virtual machine. So these processes marked in red are the new for the Android. So already we have a Java compiler. Why do we need a DX compiler? Basically this DX compiler optimizes code compared to the Java compiler. So it optimizes at such a level that the overall Dalvik bytecodes become so very small, so it runs very fast on the DVM. Basically the Java compiler is pretty verbose. The Java bytecode is, if you try to decompile it, you can get almost your whole code back. But with the Dalvik bytecode, that's not the case. It's pretty difficult to decompile, and if you are able to decompile, you won't get your source code back. So that's the difference between the two processes. Now let's look at the difference between the JVM and DVM. So with respect to these attributes, architecture base, basically DVM is based on the register base, whereas JVM is stack based. What do you mean by it? The register base is nothing but like this, where you have to refer operands directly. So here we are trying to add two numbers, so the instruction becomes add R1 R2 and store the result into the R3. So this becomes a very less number of instructions, whereas JVM is based on the stack architecture. So in order to add two numbers, you have 4 lines of instructions. The pop and push operations comes into the picture. So with this example, you must be able to understand that the number of instruction would be fewer in a register base and more would be the JVM. But on the other hand, the length of instruction would be more on DVM, that is the register base, and the less at the stack base. And the file format, as I told you, that's a Dalvik bytecode, which is .dx, and in JVM we have .class. So basically Android Java consists of a Java AC, that's a standard implementation, minus AWT swing. This AWT swing is completely removed from Android Java API, and plus they have added their own Android API. Basically this API was required for touchscreen support. So this Android API has been added to the overall Android Java, but AWT swing has been completely removed. The next are Android features. So basically application framework enabling the reuse and replacement of components. This is quite important feature. I'll just explain this with example. For example, your application needs to capture an image. So you don't need to write a different program to capture an image using a camera, store it. What you need to do is you need to call the camera activity. What it will do is it will do its work, and it will give you back the control as if it's a part of your activity. So you don't need to you don't need to create you don't need to create a code for each and every work. It's already there, you just need to reuse it. Like the camera, even the Wi-Fi accessibility, you just need to call that in, and it will just switch on your Wi-Fi. So that's how this framework is pretty important and gives very flexibility to the developers. The Dalvik virtual machine, we have seen enough of it. Then optimized graphics for 2D, 3D graphics, it is based on OpenGL. Then the SQLite, that's a persistent data storage in the Android. Then we have a lot of media support. It mostly supports the common media format, which includes audio, video and images. Then these last 3 features are hardware dependent. That's a GSM telephony, then the Bluetooth, 3G, Wi-Fi direct. These are hardware dependent. If your hardware provider is providing, then those would be there. Then the camera, GPS, compass, accelerometer. This is a list of Akash tablet features. We have ICS, optimized graphics support, we have Wi-Fi, camera with VGA camera, then accelerometer. Accelerometer is nothing but if you just change the direction of your tablet, the screen would change accordingly. That's the accelerometer. And the SQLite and the media support. Application fundamentals. Basically APK file format. Now this APK is nothing but an executable on Android. What we have like .exe in Windows, or rather the more technically we can relate it to the jar file. So APK stands for application package. It's a zip package format like based on the jar file format. It's nothing but a compressed one. So basically APK holds your code, which is a .dx, your resources. What are the resources? Resources can be anything other than the code. Your images, your audio, video, anything. Then the assets. Assets are also similar resources stuff. The certificates and the manifest file. Manifest file basically holds the system properties, lot of permissions. For example, if your application needs to access internet, then you need to put your permission in manifest file. You can say it's a controller file or the system properties file. And once APK is installed on a device, it sits on its own security sandbox. Basically, Linux gives a unique user ID to it. It will have its own virtual machine. It will run in its own Linux process. So there is a complete isolation of application. So one application will have its own security box. It won't interfere with the other application. So it's a very great security feature. One application cannot access the other application's resources until unless it's permitted. So this is quite secure. The next are Android application components. Basically these are what you say a programming building block of Android. And as a developer you will always deal with these activities, services, content provider and broadcast receivers. Let's look at the activity. I have already mentioned earlier, activity is a component which provides a screen where user can interact with it in order to do something. I mean, if you have asked any input or open a file, that activity will need some interaction from user's side. So this activity is implemented as a subclass of activity. I have already given you an example previously. The activity they have loose framework of connected activities. In every application is something loose connection of connected activities. For example, a email application where you have an inbox. If you go to the compose email, it will call the another activity. If you press back, you will be back on your main activity. You can go to this. You can go to your drafts. That would be another activity. So this is how it just it's a loose connection between the activities. And all these components would be created using a subclass of its a parent class. That is, for example, activity, it would be activity. Then for services it would be service. Now a service is a component which can perform long running operation, like for example upgradation of something, like upgradation of a PDF, upgradation of any of other software in your tablet or mobile. So that would be a service. It won't have any user interface because user interaction is not required. So a long running operations can be created using services. It is implemented as a subclass of service. The content providers. The content provider manages a shared set of application data. So there will be requirement that a common set of data would need to be accessed by the different applications like contacts. So the content provider will allow you to do that. Using content provider you can access that shared data. Again, it is also implemented as a subclass of content provider. Then the broadcast receiver. It's a component which responds to the system-wide broadcast announcements, like the battery is getting low, you have a missed call, your Wi-Fi has turned on. So even you can receive this announcement at your application. For example, if your application is based on some networking, so you need to understand whether Wi-Fi has been turned on or not. So you can just receive this broadcast announcement at your applications also using broadcast receiver. So a broadcast receiver is implemented as a subclass of broadcast receiver. I know, this was a quite brief overview because we at the last session of this day, we have a dedicated session on basically on these all building blocks, because these are very important to understand as a developer. So you have a dedicated session in detail in technically you will understand how to create all these components. So there you will come across, yeah, this is nothing but a activity life cycle diagram. We have seen what is an activity. It is a something which has a user interface where user needs to interact with it. So all these actually components have their own life cycle, but I am emphasizing on activity because that would be the start point of most of the application. So this is the activity life cycle diagram. So when activity is launched, first of all on create, then start, on resume. Basically this is the part, after on resume it would be present in the foreground for user to interact. It would be waiting for user to interact. Once it's running, then maybe on pause might get called if another activity comes into the foreground. For example, from inbox I want to go to the compose email. So for inbox activity, on pause will be called. All these gray blocks you see are the methods which you can use in activity. So if you have a class which extends activity, you can write all these methods and you can code inside it. For example, if on pause you want to free up some resources, you can do that. So on resume, you want, for example, if it's in foreground, you want some other apps to know that this activity is in the foreground, then that code you can write. So when on pause is getting called, it may, process can get killed if some apps with a higher priority need some memory, or if activity is no longer visible, it will call further on stop. From on stop again, activity can be recalled using a on restart, not directly on start but on restart. So if user, if it's pause, it has went to the background. For example, from compose email I have clicked on back button, so I want my inbox activity to be back. That means user has navigated to the activity, so on start will be called, and then resume and activity would be in the foreground. So after on stop, there is obviously, if you want to just activity is finished its work, then it can be destroyed by the system and activity would destroy. So this is just a brief overview of activity life cycle. So in the summary, what we have seen is a different Android version and API, the architecture, the DVM, JVM, the features, Android building blocks, and these are some references where you can, the developer.android.com is the most important website. It's like a bible for Android developer, so you can go ahead and visit to it. Thank you so much for listening. Thank you.